doing? That's just okay. Now we need to see the presentation. All right. So today we'll discuss about input validation and exception handling. This is Unit 3. So we'll discuss garbage in, garbage out, the input validation loop, and defensive programming. So this is maybe I don't know, 9 or 10 slides. We'll go through this and then we'll go through the other slides on what do you call it? On exception handling. So what is input validation? So if a program reads and data as input, it will produce bad data as an output. Program should be designed to accept only good data, and input validations, all inputs should be inspected before processing if it's invalid. It should be rejected and the user should be prompted to enter the correct data. What's an example of this? Let's say you went to a website and you're trying to fill some form. Now this form can be your name, your personal information, and so forth. Now it says put your name in, your first name, you put your first name in, put your last name in, you put your last name in. And then it says put your email in, instead you put in your phone number. And then it says put your phone number in, and you put your email in, because you're not paying attention. And that does happen all the time. Or sometimes you just press enter without filling that field in. So if there was no input validation on the person who developed that form, that data will be taken and stored in the database somewhere. So this is garbage in. Now somebody's going and checking this database and then looking at the forms that have been filled. Then you have first name, last name, email, and phone number like everybody else is putting in. And then there's this person, they have first name, last name, and then they have phone number and email instead of email and phone number. Now, does the data look good? Reading it, the data makes it hard. Analyzing the data makes it hard. Does that make sense? Therefore, you have what? You took a garbage in. And if you wanted to do something out with it, then you are basically dealing with a data that's bad. So this is what we are talking about. We are taking every bad data. Now, there are two options to deal with this, all right? So this is an example. Let's look at this. So you put a garbage in, that's bad. You'll get a garbage out, that's bad. So this is a pseudocode here. You'll see declare real hours, pay rate, gross pay. This is the example we have seen before in chapter 1 or 2, whichever it was. So here it says enter the number of hours worked. So somebody puts in 400 hours. Can you work 400 hours a week?
No.
And then it says enter the hourly pay rate, and then 20, fine. Then the gross pay is that. And then imagine you print this check to this if you are the manager. Who's going to get fired? The employee or the manager? You understand? So this is what we are talking about. The system should say, no, this is impossible. I mean, are you living on another planet for you to be able to work 400 hours in a week? Okay, so this is an example of garbage in. Okay, so a computer cannot tell the difference between a good data and a bad data. This is where the question comes in, is the computer smart enough? The computer is only as smart as the program or the developer. Okay, if you didn't do any check, the computer will just take it. So if your user provides bad data, a program will produce bad output. So this is where the GIGO or GIGO come in, garbage in, garbage out. It's important to design a program such that input is never accepted. Okay. So then you would have to do what's called a loop, which we will discuss later. So input validation is commonly done with a loop that iterates as long as input is bad. So it will ask you, put your email in, and then you put your phone number in. No, this is bad. And then it will ask you again. And then it'll be like, what's wrong with this form? Because you're not reading the instruction in that. It says put an email in, not a phone number. And it gives you a red text each time. Oh, I'm just putting it in. Oh, it says an email. Okay. Or even it might be that it's asking for email, and then you're putting in whatever your email is at whatever the domain is, and then you're leaving it without saying .com, .org, .edu, whatever. Does that make sense? So, but you're only looking at the first part. An email should be something at something .something. Does that make sense? So now they do have exception handling that's done for try and catch that's already created for almost all high-level languages that you can actually use if it was an email. If it was phone number, they would have it created. It would be 10 digits if it was US and Canada, right? But then again, other countries, is it always 10 digits? Does that make sense? So if it was UK, it would be bad. Like the area code alone is like 4 or 5 numbers or something, right? Okay, so you have to pay attention to that. In other parts of the world, the number might be small and the area code might be long. Okay, so you get the input, and then you do the input validation. Is it good or bad? If it's good, if it's a bad data, then you say display an error message, and then get the input again. Then you ask the question again. Please put it in. You'll probably do this in your project 3, I believe, or 4. When the customer gives you, let's say you tell the customer, I need $20 or $25, that's how much your food costs. And the customer gives you $10. The system's supposed to reject it, and you're supposed to say no. You owe 25. So you got to keep repeating that question, keep looping it, and we will discuss loops later. And if the input is not bad, then you go forward. Okay. So this is a sample of how the loop looks like. Priming read is the first input to be tested. Get a test result, display enter as a test score, input score, make sure if it's lower than 0, while the score is less than 0 or score is higher than 100, then you display an error. Because the lowest you can get is a 0, right? And then the highest you can get is 100. So if it gives you something less than 0 or something greater than 100, that's when you display the error. This is impossible, right? Then say display the correct score, then input the score. Then you ask the question again, and then you end the while loop. So you got to keep on asking that question until you get the correct data. So inspecting input before it's processed by the program. So you have 2 choices. So when you go to those forms and you're filling out the information, sometimes you see the error handled at the input. It will just show you a text thread message saying, oh, this is how it's supposed to be put in. Or sometimes it's just information next to the box say, this is how you should be putting it. Okay? Or you get maybe some type of JavaScript error at that screen. Or you can press submit and then handle it in the back end. Then you get an error back from the server and they say, no, this is not possible. This is how you're supposed to put it in. Okay? So if input is invalid, prompt the user to enter correct data, commonly accomplished using a while loop, which repeats as long as the input is bad. Okay, so in your case, you'll be repeating as long as the money is not enough, you'll ask, can I have more money? Okay, if an input is bad, display an error message and receive another set of data. If input is good, continue the process to process the input. So writing validation functions. So for complex validation, it's recommended to write a function. Okay, this process can make the code look cleaner. Then you have validation string input. So some strings must be validated, such as those programs that ask for specific string input like yes. So you can hard code this. It's either yes or no, instead of giving the option the user to type it. Or programs that specify a string to be a specific length, like password validation. Okay, so for example, if it's expecting 8 characters, then you create a box, a text box that's 8, and then because you already know, you can say I need 8 characters, not 7 or not 6 or not 9. Okay, if the field expects the last name to be at least 2 characters or 3 characters, then you put that field. Okay, but you have some people that have last name that's maybe 20 characters long, right? I don't know if there's 20 characters. It is. Maybe people from Eastern Europe, right? They have long last names, like Schwarzenegger, like Arnold Schwarzenegger. How many letters are those? I don't know, people from parts of West Africa, they have also long last name, right? So there was a video that I saw that was quite funny. He would ask the person, what's your name? And then he has like a whole statement. You saw that? Yeah. Okay. So if those people exist, then of course they exist. So we'll have to create a text box, right? That's able to handle it. And then you have people that have short last name. Okay. Short last name, how short can it be? 2 letters, 3 letters? Okay. So I have 3-letter last name, so it's easier to find something. All right. So again, so there are 2 parts. So one part you handle the text box, you can create that. Okay, if this was a form. Okay. The other part is to give them a direction of what it should be, and the third part could be handling from the server side. Let's see. So input validation is a defensive programming, so the practice of anticipating both obvious and unobvious errors that can happen. So types of error to consider: empty input, meaning that somebody presses enter before they put it in. Where a user accidentally hits an enter before they enter data, the user enters the wrong type of data, and that's the other one that you expect. For example, email, you're expecting email and they put in a phone number, so that's not good. Okay. And then when you're programming, another thing to consider is who are you programming for? What's this program about? What country are you in? Like, for example, if it was a date field and you expect a date to be entered, if it's in this country, how do we put the date in?
Month, day, year.
So we put the month, the year, and in the year. Sorry, it's the month, the day, and the year, right? What do you think the rest of the world will do?
Day, month, year, month, day.
It's the day first, then it's the month. So they go in order, right? That makes sense? The rest of the world, they are together on this. Only the US, you have it the month and the day. So when you're writing the program, you have to think about how you're writing it. Then again, imagine if you are in Ethiopia or if you are in China. Ethiopia has how many months? Yeah. So you gotta know, like certain countries have different dates, right? In Ethiopia, they got 13 months, right? So you got 13 months, so you gotta consider that, okay? Certain countries have different dates that they use. China has what? What year are they in now? Like a couple years off, right? Or was it Ethiopia that was a couple years off?
I think China's the same year. They just celebrate New Year's like on the 13th of January or something.
Okay. Ethiopia right now, it's what? 2020, 2019 or 2017? 2012? So they are like 8-year difference. So you got to think about what you're writing and what you're doing. Okay. 2012. Okay. So you have to. These are things that you have to consider when you're writing program and who you're writing it for. Okay. You have to be very considerate. Right? So these are part of the defensive program. So common errors to be aware of. So state abbreviation should be 2-character string. Zip code should be in the process format of 5 or 9 digits. You have zip code here, then you have, let's say if it was Canada or if it was UK and these other parts of the world, they have what? Instead of zip code, they have postal code. So they have letters and numbers all mixed. Okay. Hourly wages and salary amounts should be numeric value and within range. Dates should be checked. Time measurements should be checked. Are you using inches? Are you using feet? What is it? Meters. Okay. Check for reasonable numbers. Any question? So that was the general explanation of it, and then we will discuss the part that deals with the approach. This is the file and exception handling topic. It's basically a continuation of what we just discussed. So for a program to retain data between the times it's run, you must save the data. So data is saved to a file, typically on a computer disk. Saved data can be retrieved and used at a later time. Okay, writing data to saving data on a file or output file is a file that data is written to. Okay, so an example of the pay rate, employee ID, and employee name, data is copied from the memory, RAM, and then saving it to a disk file, right? So reading data from a process of retrieving data from a file, an input file, a file from which data is read. So 3 steps when a program uses a file. So you open the file, you process the file, you close the file. As you're doing this, what happens if there's an error? There is no file that exists, or there's no file to read from, or there's no file to write from. Again, what do? We go back to the exception handling, right? The input validation. So reading data, the same thing. So you go to the file and you read from it, okay? And you keep it in the temporary memory RAM. So in general, there are 2 types of files. You have text file, contains data that has been encoded as text, and then we have the binary file, contains data that has not been converted to a text. So 2 ways to access data stored in a file. You have sequential access. You have sequential access, file read sequentially from the beginning to the end and can't skip ahead. You go one after the other. Then you have a direct access. You can jump directly to any piece of data in the file and grab that file or that data. Okay. File name extensions is a short sequence of characters that appear at the end of a file name preceded by a period. So extension indicates the type of data stored in the file. So what's an example of a file extension that you know? .jpeg. To show what? It's an image. What else? .html to show it's HTML file. What else? TXT to say it's what? A text file. .py. It's a Python. We discussed that on last class or the class before, right? How about if it was a Raptor? Right, right? RAP. How about if it was Microsoft Word?
docx.
So you can have it at DOC or DOCX, right? Both are valid. Okay, so that's what's called a file extension. So sometimes you have to add that when you're reading or writing to a file to specifically say the type of file you're trying to read. Your file object associated with a specific file, so provides a way for a program to work with the file. So file object referenced by a variable. Okay. So a variable name preference is a file object that is associated with the file. So opening a file, so any of these files, if you're trying to read it or write it, so we have functions that are built in each language that you can use. Open function, so used to open a file, creates a file object and associate it with a file on the disk. So the general format is file object, and then you open it, and then whatever the file name is, and the mode. Mode meaning, are you reading, are you writing to it, whatever you're doing. So mode is a string specifying how the file will be opened. Example is reading only. So you can only read that file. Writing, W, you can write, and append something to it. So it's specifying the location of a file. So if open function receives a file name that does not contain a path, assume that file is in the same directory as a program. If it's not in the same directory, you have to say it exactly what directory it is. It's in the C drive, in my desktop, in this folder, and so forth. If a program is running and file is created, it's created in the same directory as the program. You can specify alternative path and file name in the open function argument. And the prefix, the path, the string, literal with the letter R. Writing data to a file, so it's a method, a function that belongs to an object, performs operations using that object. So file object's write method used to write data to the file, and this is the format. You have file, variable.write, and then the string. File should be closed using file object close method. This is the same almost in all languages, using the function called close. Even with the databases, if you had to read file from a database, and you have to make sure that you close that, there's no memory leak. Okay. You have a read method, file object method that reads the entire file contents into memory. Only works if a file has been opened for reading contents returned as a string. You have a RedLine method, file object method that reads as a line from the file, and line returned as a string, including the /n as a new line. Read position marks the location of the next item to be read from a file. Then concatenating a new line and stripping it from a string. So what does concatenating mean?
Combine two.
You're not adding it, right? Like sometimes kids will ask you as their riddle, what's 1 + 1? And then you'll be like 2. They're like, no, it's not 2. They say it's 11. Why do they say it's 11? What are they trying to do? They're concatenating. They're not actually using the plus sign as addition. They're using concatenation. They're saying 1 next to 1. So they're bringing the 2 ones together. So what they're saying is I have a string of 1 and I have another string of 1. And if you add the 2 strings, it becomes 11. They're not saying that. They just, I don't think they're making it that complicated. But they will tell you it's 11, right? So that's what concatenation is, putting 2 things next to each other. All right? So in many cases, you need to remove the /n from a string after it's read from a file. Or a strip method, so a string method that strips specific characters from end of the string. Again, these are some of the built-in functions that come with this. So when you open a file with a W mode, if the file already exists, it's overwritten, it overwrites it. To append data to a file, use the A mode. So if a file, or the append mode A. If a file exists, it's not erased. And if it doesn't exist, it's created. Data written to the file at the end of the current content. Okay. writing and reading numeric data. Numbers must be converted to a string before they are written to a file. So str function converts a value to a string. Number are read from a text file as strings. And it must be converted to a numeric type in order to perform mathematical operations. So like use int and float functions to convert string to a numeric value. Using loops to process file. So files typically used to hold large amounts of data. So loop typically involved in reading from and writing to a file. So often the number of items stored in a file is unknown. So the RedLine method uses an empty string as sentinel when the end of file is reached. What is a sentinel? What is a sentinel? It says the RedLine method uses an empty string as a sentinel when end of file is reached. I haven't explained to you this. When I get to loops, I'll be explaining. I just want to know if any of you have an idea. And a sentinel is basically you're throwing something at the user that is not normal from the input you have been taking. For example, you tell the user, you have been asking numbers, right? And then you tell the user, put an A in to end the program. Or something to control, to say, put a yes or a no in. Does that make sense?
So like a variable that you put in.
You can put a variable in, it can be a number, it can be anything. Okay, so you put that in to halt whatever the process the program was doing. And you can write a while loop with the condition while line is not equal to, and then whatever the quotation. So the general logic for detecting the end of a file is open the file, use the read line to read the first line of the line. The read line return an empty string. If it's no, then process the item that was just read from the file. Use read line to read the next line, and then if it was true, then close the file. So Python allows the programmer to write a for loop that automatically reads lines in a file and stops when the end of file is reached. So you have format for line in file object in this statement. The loop iterates once over each line in the file. Processing records. Record is a set of data that describes one item. Field is a single piece of data within a record. Write record to a sequential access file by writing the fields one after the other. Read record from sequential access file by reading each field until record completes. When working with records, it's also important to be able to add records, display records, search for specific record, modify records, delete records. An exception is error that occurs while a program is running. Exception is what we were talking about when we were dealing with input validation. It's pretty much the same thing how you handle it. Usually causes a program to abruptly halt. So it traces back error message that gives information regarding line numbers that cause the exception. And remember, when you run any program Python, if you misspell something, it will give you a traceback error. Okay. It indicates the type of exception and brief description of the error that caused the exception to be raised. Many exceptions can be prevented by careful coding. So example is input validation, usually involve a simple decision construct. Some exceptions cannot be avoided by careful coding, and these examples are trying to convert a non-numeric string to an integer, trying to open for reading a file that does not exist. Maybe I'll show you that example there. And the exception handler, so code that responds when exceptions are raised and prevents program from crashing. So in Python, write a try except statement, and generally you can write a try statement, except exception name, and then a statement. You have a try switch statement that can be potentially raised an exception. You have the handler statement that contains the except block. If a statement in try switch raises an exception specified in except clause, handler immediately following except clause execute. Continue program after try and except statement. Other exceptions that program has with a traceback error, and there's nothing you can do. You want to be able to continue and take it back to the user, so they have an option. If no exception is raised, handles are skipped. So handling multiple exceptions, so often code in try suite can throw more than one type of exception. You need to write the except clause for each type of exception that needs to be handled. So an except clause that does not list specific exception will handle any exception that's raised in the suite. So it should always be the last in a series of except clause, displaying an exception's default error message. Objects created in memory when an exception is thrown, so usually contains a default error message containing the exception. You can assign the exception object to a variable in an accept clause. An example of that is the accept value error as error. You can pass exception object variable to a print function to display the default error message. I'll do that. Then you have the else clause. Try except statement may include an optional else clause, which appears after the accept clause. Align with try and accept clause, so syntax similar to else clause in the decision structure. Else suite, block of statement executed after statement in the try suite, only if no exceptions were raised. If exception was raised, the else suite is skipped. The finally clause, try except statement that may include an optional finally clause which appears after all the accept clauses. So aligned with try and accept clause, general format is finally, and then you write the statement. The finally suite block of statements after the finally clause executes whether an exception occurs or not. The purpose is to perform a cleanup before exiting. What if an exception is not handled? So you have two ways for exception to go unhandled. No accept clause specify an exception of the right type. Exceptions raised outside of try suite. In both cases, exceptions will cause the program to halt. So Python documentation provides information about exceptions that can be raised by different functions. So this was basically as a concept, but I will show you an example, a quick example of the try, especially because you will need to be able to handle input validation and exceptions. But we will go over later about loops, and then once we go over loops, I'll show you how to do that in Raptor, and we will do loops in Python. But I just wanted to show you this exception handling. So here's an example of the try and accept that we just discussed. It's a whole suite, it's long. But here it says try with open, use open to file, open this file called log as file, read data, and then file, read. So accept, and if you cannot read it, then we need to be able to put out some message, say, oh, we couldn't open this file. Okay, so if we run this, you should get this message. So it says, oh, we couldn't read this file called file.log. We know what this is, right? So you have to specify specifically the type of file you're trying to read. How about if we actually add the file? Okay, here, because it's in the same package, we can create a file here and then create a file called file.log. We can match it, okay? And now how about if we run the program? Okay, there's nothing there because we didn't get the error. It's able to read. It knows that this file exists. Does that make sense? So, but if we didn't have this, it will get to this. But because it's able to read, it will skip it. Does that make sense? So this is just a basic of try and catch. And when you come to the Java or the C++ class, you will have to write the try and catch or try except. Okay, these are just exception handling. And this was in the case of the file, if you had to read a file. Okay. And then in the case of the loops, I'll show you for Raptor and Python once we get to it. Because there are a lot of things you can accomplish with loops and if decision statements without using the try, but if it's for bigger programs and functions, then it's better that you have to write some try and catch or try and accept suites. All right.